And welcome to the Power Grid International webinar, Aerial Covered Conductor Systems as a Wildfire Mitigation Tool, brought to you by Hendrix. I'm Power Grid International Editor-in-Chief John Engel. All right, so let me set the stage for this webinar. Recent years have shown an increase in wildfires in the western regions of North America. The wildfire-prone regions are growing, as is the damage caused by those fires. While an objective of system designers is to harden the electrical grid infrastructure to survive wildfires, a more pressing concern is to design and build power lines which do not cause ignition in the first place. This webinar will describe how wildfires are initiated and the challenges power lines face in wildfire-prone areas. We'll discuss fire-related characteristics of bare wire and underground systems, fire mitigation techniques offered by both spacer cable and tree wire systems, and the effectiveness of various fire mitigation strategies as evidenced through lab and field testing. Please also check out the documents in the handout section of this platform to follow along and get additional information. I'll pop back on for the Q&A, but for now, I'm excited to turn it over to Brian Traeger, Director of Technology and International for Hendrix. Brian, you can take it away.
Thank you for that introduction, John. So, hello, good morning, participants. Thank you for taking the time today. It's always a privilege to share new ideas and new technology with my industry. As John said, we're going to talk about aerial covered conductor as a wildfire mitigation tool. In the presentation, we'll talk a little bit about wildfires and power lines, and then talk about how different construction types respond, going to undergrounding, and then the different types of covered conductors that we have. And then we'll talk a little bit about the testing, so objectives and motivation and the conclusions. So one of the big things is lines blowing into trees during high wind events. They could have enough current to cause ignition, or they could cause a spark. We're talking about downed lines, when lines actually come off of the pole and lay on the ground. We know that 30% of the cases where the conductors hit the ground are what we call high impedance fault. We don't have enough current to trip a fuse or a breaker or what have you. And those lines for a high impedance fault will lay on the ground until it may be too late, until we have a fire. And then sometimes they will call and it will be too late. Then we have vegetation contact. We may have a tree branch above contacting two lines that might be there for an hour, 24 hours, who knows, on there long enough to draw enough current, maybe burn the line down, or have a branch in flames fall to the ground and ignite dry brush on the ground. A couple of mechanisms there that could turn into a fault, turn into a wildfire. We have conductor clashing. Conductors may be flopping back and forth in high winds. If their bare wires slap into each other, this is going to cause really super high temperature plasma to fall onto the ground and certainly ignite anything there. And then we have what we call repetitive faults. We keep getting the same fault on the same feeder. If each fault creates some risk of failure, we may have aged equipment. That's going to add to the possibility, blown bushings, what have you. So we got to be cognizant of those ignition sources. And then we have apparatus failures, whether that's bushing, cap banks, clamps, line switches. And over time, they can increase in intensity and ignite what we call proximate combustibles. So we want to hopefully avoid that as much as possible. Here's perhaps the most insidious and perhaps the most preventable, what we call mylar balloons. So we've got statistics from Southern California, Edison, PG&E, up 1,000 or more faults caused by mylar balloons. And when they go, the explosion is unbelievable. And they can blow all kinds of hot stuff on the ground and start a wildfire. And they have started wildfires in numerous cases, both in California, Arizona, and surrounding areas. California introduced legislation just recently for a new mylar balloon. Those balloons will be outlawed in 2031, but no doubt we're going to have a good additional 8 years of wildfires from mylar balloons. If we were smarter as a society, we wouldn't be promulgating. Here's a big question. We were working with wildfire mitigation since the 90s with the Australians. When we talked to the Public Utility Commission in Victoria, do you want your equipment to survive a wildfire, or do you simply want it to avoid being the cause of a wildfire? If we want to survive it, it's not always possible. It's not easy and it's not cheap, surviving wildfire. How do you Hardened systems do monitoring, certain relaying, REFCL, neutral equalizers, fiberglass cross arms, steel poles, simulation, monitoring. These are things that really need to be done. We are talking here about avoiding causing a wildfire. Options exist to mitigate against the possibility of a power line starting a fire. Our objective is to eliminate the possibility of a wildfire being caused by an electric utility power line. And we'll talk about what tools and or techniques can we employ for various power line construction options and to provide a maximum assurance that they will not ignite or contribute to a wildfire scenario.